Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the structure of the atom. In our previous lessons, we have learned the composition of the atom, atomic mass, and isotope. We also identified the constituent parts of the atom. In your class, you also looked at some examples of the atomic model, a visual representation of the theories of different atomic physicists. Today, we will be discussing Bohr's atomic model. In 1913, Danish physicist Niels Bohr proposed an atomic model in which the electrons are assumed to move around the nucleus in circular orbits. This assumption was made based on the earlier Rutherford atomic model, which made the same claim. However, Bohr made some important modifications. Bohr postulated that the electrons in an atom exist in a restricted number of stable orbits with energy levels in which they neither absorb nor emit energy. The principal quantum number designates these orbits. This number is represented in the atomic model by the small letter n. The principal quantum number has a value of 1, 2, 3, and so on, depending on the number of orbits in the atom. The energy levels are called shells. These are represented with letters, starting with the letter K and increasing alphabetically depending on how many shells we have in a given atom. When an electron changes orbits, it absorbs or emits energy. When an electron jumps from lower to higher states, it absorbs a fixed amount of energy. When an electron falls from a higher or excited state to a lower or ground state, it also emits a fixed amount of energy. Bohr also states that electrons orbit the nucleus depending on energy levels. The maximum number of electrons that the main energy level can accommodate is given by the formula 2n squared, where n is equal to the quantum number representing the main energy level. When n equals 1, the main shell is K shell. When n equals 2, the main shell is L shell, and so on. Bohr also postulated that for each element, the number of energy levels remains fixed. Furthermore, each different energy level or shell of an atom can only accommodate a limited number of electrons. Students, let us do an activity. What is the major difference between Rutherford's atomic model and Bohr's atomic model? Why is this difference significant? You may begin.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. Let us closely examine the differences. On the left side of the screen, you will see the Rutherford model, and on the right side, you will see the Bohr model. Do you see the numbering system in Bohr's model, students? The major difference between the two models is that the Bohr model explains why electrons are able to orbit the nucleus without spiraling towards the center. The Bohr model also provides a numbering system by which we can calculate the number of electrons on a given shell or orbit, and explain how they shift from shell to shell. If this was your answer, great work! According to Bohr, each shell of an atom can only accommodate a specific number of electrons. He established a formula that provides us with an easy way to calculate the number of electrons at a specific energy level. The maximum number of electrons that a given shell can host is given by the formula 2n squared, where n is equal to the energy level in question. If we apply this formula on the first shell, n is equal to 1. Therefore, the first energy level can host only 2 electrons. If we apply this to the second shell, n is equal to 2. Thus, the second energy level can accommodate 8 electrons. This behavior is the same no matter how many levels of energy there are in an atom. When electrons fill the energy levels in the atom, they begin with the lowest energy level. As they fill up with electrons, we can apply the formula 2n squared to determine the location of each electron as they enter a higher energy level. Also, it is worth noting that the outermost shell of an atom cannot hold more than 8 electrons, even if it has the capacity for more. If an atom has more than 8 electrons on the outer shell, it is considered to be unstable. Here we have an example of several atoms drawn using Bohr's representation. Consider what we have learned about the 2n squared formula. If we look at the chlorine atom, we can see that there are 2 electrons at the first energy level, or the K shell, 8 electrons on the L shell, and 7 electrons on the M shell. The first 2 shells have the maximum number of electrons possible, while the outermost shell holds the remaining 7 electrons. The layout of these electrons is called the electron configuration of the atom. In the case of a chlorine atom, this is expressed as K2, L8, M7. Students, it is time for our last activity. Here are some examples of atoms with the atomic numbers provided. Can you draw these atoms using Bohr's model? You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us compare our model diagrams to see if they are accurate. Here are the diagrams for nitrogen, sulfur, potassium, and calcium. Look closely, students. Do your diagrams look the same? If so, excellent job. That is all the time we have for this lesson, students. Today, we have learned about the Bohr atomic model and the postulates of Bohr's atom. We also learned how to establish the electron configuration of an atom using the 2n² formula. Until next time, thank you, teacher. Thank you, students.